Okay, average. Well, let's start with average rate of change. That's not what we're talking about today. That's old news. But average rate of change. Do you remember what that is? Slope. I would be a little more specific, like algebra slope or slope formula. F of B minus F of A over B minus A. That's just a review topic. Average rate of change, as opposed to instantaneous rate of change. Now, the reason it's there, we're going to skip over the rest of this, do average value a different way, and then you'll see why it's kind of connected. Okay, let's just draw some kind of graph. It doesn't matter what it looks like. It probably works better if it's increasing, because it'll make more sense. From A to B. And our goal is to find the average value. So like the average height of the function on A to B. So average value, that's the same thing as the average height. Average value, same thing as the average height. And we're going to look from A to B. So I would ask you to just kind of eyeball that. What do you like the average height to be somewhere in the middle there? There's my average height. Any thoughts on how I could quantify that or figure out what that is? What would make that the average height? I can do this. There's the area under the blue curve. Here's my area under the red line, the area under the average height. And if those areas are equal, then I've got my average height. And so this is where the average height or average value formula comes from. Or that's how I remember it. The other way to remember it is over here. I don't like that way. I like thinking about the red area equals the blue area. So the red area, what shape is that? That's an easy one. Geometry students. Well, maybe it's a square, but more likely it's certainly a rectangle. So a rectangle would be just base times height, or length times width. So I'm going to do B minus A times the height is the average value. That's what I'm trying to find here. B minus A times that height the whole way would be the area of that rectangle. Okay, the blue area doesn't work so much for a geometry formula, but we know a calculus thing to do to find the area under a curve. How do we do that? The antiderivative, the integral from A to B of f of x dx. That's our calculus area. We can use that to find weird shapes. We can use geometry to find the rectangle. Well, we're almost out of space, but we're basically almost there. If I want to solve for the average value, I'll go ahead and put this in the box. I can divide b minus a to the other side. 1 over b minus a, the integral from a to b, f of x dx.
Can you scoot down a little bit?
So you can see it. That is hugely important. That's why I wanted to split this lesson up, because that deserves a day of its own, even though it feels like a fairly simple problem. You got to know that. Either memorize it or think about area. Like if I haven't done it in a while, like when I come back to it each year, I can usually start over here. I know it's the area equals area thing, and then I can come up with that equation pretty quickly. Little note there. This is always on the AP exam several times. So be careful. Let's back up a second and see why we started with average rate of change. They both have the word average in them, so that throws people off. But rate of change, we know that's a slope type of thing. Average value is not a slope type of thing. They do both have B minus A in the bottom, so that is another point of like, does that make it easier or harder that they're similar to each other? So that's why we started with average rate of change. It's just a review thing. But there's also some similarities in the name and in the formula. I can't emphasize that enough. That shows up all the time on the AP exam. Find the average value of, and so it's just another way to ask you to do an integral is really what it is. So now we can do integrals for area, we can do integrals for antiderivatives, we can do integrals to find average values. Okay, let's jump to the examples over here. So number 6, find the average value of g of x equals 3x squared minus 2x on the interval 1 to 4. Okay, I have no idea what that looks like, but that's fine. I'm just going to use the formula. Average value. Oh, I wanted to say one more thing. Sorry, back up. When you're thinking about if you think about the area formula, rather than just memorizing this formula, it's 1 over the width times the area. So that's more how I remember it, rather than trying to remember all the letters and where they go. I remember it as 1 over the width times the area, because that would give me the height. So there's the detailed formula, but like the concept formula is 1 over width times the area. And so whenever I see an average value problem, I'm probably going to start with 1 over the width times the area. And that's what kicked me back to the back page there when I started this problem. Whenever I see average value, I'm thinking 1 over the width times the area. And then I'll fill in the stuff. Some of you aren't going to memorize it that way. You're just going to memorize the 1 over b minus a integral from 1 to 4 of 3x squared minus 2x dx. To me, memorizing the concept is better because it helps me understand the concept. There's also less details to memorize, but you still have to know what is the width, what is the area. Okay, so 1/3, and then this is definitely not a safe stop. It's calculator ready in the sense that if you have a nice calculator, it's calculator ready. But there's calculus left to do, so we can't stop there. So let's see, that'd be x cubed over 3, but the 3's would cancel. 2x squared over 2. So 2's would cancel. Kind of a big problem here. Help us out. We don't write the integral anymore because we use the integral to do the antiderivative. We still need the 1 and the 4 there. Be careful, that's not a safe stop. There's not much left to do, but you have to plug in the 4 and the 1. 1/3. Plug in the 4, so 4 cubed minus 4 squared minus 1 cubed minus 1 squared. Is that a safe stop? Yes. which is good because I'm out of room, so I'll leave it there. It does reduce a lot. Like the 1 minus 1 goes to 0. 64 minus 16 is 48. 48 over 3 is 16. So either way, safe stop or do a little more work and get to 16. One over the width times the area. All right, why don't you try number 7? Same formula, same concept, different numbers, different. So that would be a safe stop, but I'm kind of curious. So 27 minus 9 is 18, and 18 over 3 is 6. So the average value of that graph between 0 and 3 is 6. Pretty rare that I know what the graph looks like, but 9 minus x squared, that one's not too hard to figure out. Upside down parabola looks like that. And we were looking for only from 0 to 3, and it turns out that average value was at 6. So there's sort of my area picture of what was going on. My red area equals the blue area. The red area, well, they're both 18. Again, it's not often you can actually draw the picture because usually the function is crazy that you can't figure it out. Number 8, with a calculator. Between 1 and 2, what is the average value of 1 over x cubed? Well, average value, 1 over the width. And as I was walking around, some of you showed the 1 over 3 minus 0, and some of you just put 3. And again, that's fine. Same thing here. 1 over 2 minus 1, just 1. So some of you are going to put it, and some of you aren't. 1 to 2, 1 over x cubed dx. So yeah, that's a calculator problem. So grab a calculator, and then compare answers, and we'll see what we get. Okay, number 9, with calculator again. Although, find the value of k such that the average value is 2 over pi. Okay, this seems more complicated than the previous ones. Average value, which we know for this one. We know the answer. The average value is 2 over pi, but we've got to figure out what k is. So my answer is 2 over pi. But let's set this up. So 1 over k minus 0 times the integral from 0 to k of sine of x dx. So the last one, we didn't really need a calculator on. This one, a calculator doesn't really help us on. Right? Because if you type in that into your calculator, it's probably going to give you an answer. I bet it gives you 0. But you can't do that because your calculator doesn't know what k is. In fact, we're trying to find k. So if you type that into the calculator, again, I think it will give you an answer, which is misleading. Right? 0 to k sine of x dx. 0. But I don't think that's right because the calculator doesn't know what k is. In fact, I know what the calculator does. If you haven't assigned a value to the variables or to the letters, it assumes they're 0. And so it just did the integral from 0 to 0, which would definitely be 0. But that's garbage. Like the calculator doesn't know what k is, so I can't do that yet. So by hand, I need the antiderivative of the sine of x. So it's cosine, but is it positive or negative cosine? Negative. Because the derivative of cosine is negative sine, so I need this to be negative cosine of x. from 0 to k. So I'm really not sure why I have a calculator on this problem at all. It's not helping me. 2 over pi equals 1 over k. Negative cosine of k minus negative cosine of 0. I guess the calculator could help you find the cosine of 0 if you were not sure. So 2 over pi equals 1 over k. I definitely don't know what k is, so I've got to leave negative cosine of k. Cosine of 0, though, I know what that is.
0.
Cosine of 0
1.
is 1. Okay, so what in the world do I need to do next? 2 over pi. I'm going to rearrange this because that just looks weird. I'm going to write it as 1 minus cosine of k over k. Cross multiply. I don't like that there's 2 k's in there, but maybe I can figure this out. 2k equals pi minus pi cosine of k. So, let's see. Cosine of... Are you going to take out a pi?
Maybe this is why we need to go. Yeah, this.
Maybe. Pi times 1 minus cosine of k. Okay. Be careful, if I divide by pi, then I'm almost back to where I started with over here. I think this is almost well, I guess this is a calculator thing. If I want to use the calculator, I need to set it equal to 0, and then just see where it's equal to 0. So let's do that. So pi times 1 minus cosine of k minus 2k. Means I could distribute the pi or not, it doesn't really matter. But I'm going to put that into my y equals. I'm going to use x instead of k. Minus cosine of x. Careful with parentheses. Minus 2x. And I want to know where that's equal to 0. So, graph. Make sure I'm in radians. I don't need to see any negatives because we're going from 0 to k, so k can't be negative. So I'll just go -1 to 3. I don't know, 2. It looked pretty small in there. Okay, so 0 would work, but think about that. If we use k equals 0, something's messed up, because what's the average value going to be if we go from 0 to 0? That's going to be 0. So I don't think 0 works. I think I need to find that other one. Second calc 0. Graph second calc 0. Left bound, right bound, yes, 1.571.
There's another 0 to the right of it. So wouldn't that...
Is there? There is another one.
So
That other one is probably pi, because that looks like pi over 2. Are there two answers? So I think there are two answers. This is
Will one be like this? We'll get it. Come to us like this on the test. I really like that.
I think I'm okay with either one of those answers.
Or at least make it multiple choice.
I didn't like 0, and I'm pretty sure it didn't go past pi.
It's like that it is. You should have already known that.
Yeah, it went down after that. So I think there were two answers to that. Yes. Okay. Well, you don't have a calculator on the test. So if they're like that, they're going to have to be easier on the algebra. Does that make sense? Like, once we get to here, we had to go to the calculator. On the test, when you get to here, it'll need to be easier, and it needs to be able to be solved without a calculator. So, yes, but not as bad. Okay, I want to save that last example problem. That's kind of something else. So let's save number 10 till Friday. So back on the worksheet packet, today's assignment is 7 through 14. And they're all, what is the average value? Find the average value. What's the average value? Find the average value. You know what? Let's do... Oh, that says with calculator. Yeah, let's do number 12. Because that one is similar to the one we just did. So while it's fresh on our mind, you got a calculator, but I don't know that it's going to do you much good initially. So try number 12. So there's the setup to number 12. So I think today's a pretty easy day. Another day to finish before you leave even. Don't have those very often in here. Because all you have to do is 7 through 14. We just did one of them. So that leaves 7 left. And you're saying you're going to skip the calculator, but the 2 remaining calculator problems are easy calculator problems. Super easy calculator problems.